This video introduces one of the main features of 2D target object recognition, namely positioning and picking, and explains how to configure relevant parameters using the 2D target object recognition tool. In positioning and picking scenarios, when the z-axis height of identical target objects is consistent, 2D target object recognition allows a 2D camera to recognize the pose of objects on the XOY plane. Then, it converted the 2D pose into a 3D pose to guide the robot in picking the object. Next, we'll take the positioning and picking of flat sheet metal parts as an example to demonstrate the configuration process. In this scenario, the overall recognition process includes 4 steps: image preprocessing, target object recognition, target object pose calculation, and general settings. During image preprocessing, color space conversion is used to adjust color and brightness information, highlighting the features of the target objects. Enhancement and denoising operations can also be applied to improve subsequent recognition results. For target object recognition, it's necessary to set the region of interest and flexibly select the recognition method based on object features. Then, adjust parameters accordingly to accurately recognize the target objects. After recognition, using the camera's extrinsic parameter calibration data and the reference object's teaching information, the recognized 2D pose of the object is automatically converted to the 3D pose required for robot picking. In general settings, configure pose filtering rules and output ports to ensure the results meet the requirements for subsequent picking. Now, let's move on to the configuration process. Open Mech-Vision. Before proceeding, make sure 2D camera hand-eye calibration is complete, and the camera can capture images normally with quality meeting requirements. For this scenario, it is recommended to increase the exposure time in the image acquisition settings so that the object pixel values approach 255. This setting effectively eliminates noise such as surface scratches and textures. By preventing internal noise from affecting the match, it enhances outer profile stability and ensures reliable picking under varying conditions. Then, locate the 2D target object recognition step. Click Config Wizard to enter the tool interface. Select the appropriate scenario according to the description. In this case, choose Positioning and Picking. Since the sheet metal parts to be recognized have regular and fixed shapes with clear edges, select the 2D template matching method. After this, begin the specific configuration. First, preprocess the images. The current image is clear and well exposed, showing distinct object features, so preprocessing is unnecessary. In actual applications, the relevant parameters can be adjusted as needed. Click Next to enter the target object recognition process. First, set the recognition region. In this scenario, the sheet metal parts are closely clustered in a limited distribution region. To improve recognition efficiency and accuracy, it's recommended to select Customize Recognition Region. Set the recognition region slightly larger than the bin to cover small positional deviations that may occur during loading. Then, generate the target object template, and ensure the system will automatically locate objects in the image that match the template's features. Click Edit to enter the 2D matching template editor. The image is automatically acquired and you can name the template. Then select the feature region to quickly generate a template. It's recommended to choose a sheet metal part with clear edges, stable recognition features, and no overlap with other parts as the template. When drawing the template, use the polygon tool and click 4 key points along the outer profile. The drawing range should be slightly larger than the object edge. This ensures complete feature extraction and improved positioning accuracy. After selection, the object center point has been generated automatically. Generally, the default settings are appropriate. If needed, adjust the center point through Edit Center Point. At this point, generate the template and check the extracted edge features. Adjust feature parameters if needed. It can be observed that green points exist outside the profile within the ROI. This results from a low fine edge threshold, which leads to the background bin's texture being falsely recognized as features. Therefore, increase the fine edge thresholds to filter out noise points and improve matching accuracy. Additionally, as seen in the image, the orientation of the sheet metal parts is random. Increase the angle search range to ensure all rotated objects can be recognized. Considering that the size of the object may vary slightly during actual image acquisition, appropriately widen the scale ratio search range to improve the template's adaptability to object size variations. After completion, generate and save the template. The edges extracted for the current template are continuous and form a closed loop, with no obvious breaks or noise interference. The quality of the edge feature extraction meets the requirements. Then, save the template. Click Update to apply the latest template configuration. Select the generated template. Then, based on actual requirements, set the max number of matching results. This limits the maximum number of results output each time. After setting, run the step to check the recognition effect. Green matching points cover the outer profile well, indicating good recognition. The few red points are caused by object overlap and high brightness reflections. Since confidence is high, no further adjustment is needed. Then, click Next to start the object pose calculation. Finish the teaching process based on operation instructions and required pose values. Please note that the teaching process and parameters differ between eye-in-hand and eye-to-hand scenarios. This case uses the eye-to-hand scenario. Now, let's move on to the teaching operation. First, clear the bin and leave only one object as the reference part for teaching. Click Run Project. Acquire and recognize the reference object. Then, select the 2D camera step with completed extrinsic parameter calibration to ensure calibration data is correctly applied. Click Acquire to get the current 2D pose of the reference object. Please note that the object pose should be fixed during the teaching process. After recognition, use the teach pendant to control the robot so that the gripper can position precisely at the expected picking point. Click Edit to enter the robot flange pose. After that, ensure the object remains stationary and use the teach pendant to move the robot away from the picking point. Click Run Step to check the object's 3D pose in the recognition result. At this point, the teaching process for the eye-to-hand scenario is complete. The system can now automatically calculate the 3D pose required for robot picking based on the recognized 2D pose. Click Next to enter general settings. Before the specific configuration, place the objects back into the bin and click Run Project again. This allows the system to perform batch recognition and output the picking poses for all objects. In General Settings, configure pose filtering rules and output ports as needed. Here, pose filtering is used to exclude poses with potential collision risks or execution constraints. In this scenario, parameter adjustment is not needed. Adjust settings according to the actual situation on site. Please see the documentation for more information. In this scenario, output ports output the target object name and recognized pose by default. To evaluate matching quality, please select the Matching Score port to output a list of matching scores. Click Save and return to the project interface. Now, this completes the 2D target object recognition configuration for positioning and picking sheet metal parts. Next, connect the output step to view the overall execution results. In this scenario, the point cloud model matching is not needed to acquire pose. So, according to the instruction of Select Scenario, select Depalletizing and others. After scenario selection, set the target object. Open Target Object Editor, select For Picking. Select No Point Cloud Model Required in Select Configuration Workflow. After entering the interface, save directly without making any changes. Then, under Target Object Without Point Cloud Model, select the object you just saved. Next, since collision detection via point cloud is not required, uncheck the point cloud settings in the collision detection settings. As this scenario outputs multiple objects, check Pick Point Labels to display the object name. Then, connect the corresponding step port and click Run. The recognized poses can be sent to the robot for subsequent picking. For more information on 2D target object recognition applications, please watch the other tutorial videos and refer to related documentation.